Hi and welcome to a maths high level video. I'm going through power series. So what are power series? We're going to use them to approximate functions, okay? Now, this is just a type of series, and within this type of series, we'll have other types of series. So this is more a general type of series of the ones we're going to be using more, which are Maclaurin series and Taylor series. The general form of power series is this one. Now, this doesn't look very friendly. This thing here is just going to be a general term within the summatory, okay? Now, it's going to be something like 2k, and if this is 2k, then this a0 will be 2 times 0 is 0, a1 will be 2 times 1, 2, here we'll have 4, and then 6, and so forth. So you're going to have a general term here. So this a to the sub k shouldn't be that scary. Here you're always going to have x to the power of k. Now this is important. In power series, you always start with no x, x to the power of 1, x to the power of 2, x to the power of 3, x to the power of 4. That's the thing about power series. That's why they're called power series, because you keep having increasing powers of x. Now we might have this xb minus b or plus b or something like that, and that's another part of what the power series looks like. This is just going to be a constant term for all of the elements of the series. If b is equal to 2, then we're going to have a1 times x minus 2, a2 times x minus 2 squared, and so forth. And this is the general formula of power series. And these are the ones we're going to be using to approximate functions. Now, the only time when these ones are really going to be approximated functions and we can actually use them is going to be when they converge. So all of the time, our main concern is going to be, do these series converge? And we're going to be using all of those tests that we had before to determine this. So often b will be equal to 0. And it might be that it will only converge for one value of b. We'll talk about this in a minute. You're going to see it. But the important thing to realize here is that your power series are going to converge for certain values rather than b of x. That's what's really going to happen here. And sometimes it will converge for all values of x. So let's find out how it converges. Remember, this is general form, a general term here, and just a constant here, and the x having increasing powers. Let's find out how it converges. So let me start with a simple example. Let's have b equals 0. Now, if b equals 0, you're going to get the following thing, right? You're going to get a 1, say x by x squared, and so on. And that's going to be where you're going to get. But this thing here is just a geometric series, right? In which this part is the ratio. So when is it going to converge? Well, it's going to converge if this is smaller than 1. The absolute value of this thing here is smaller than 1. And when will that thing happen? Well, that thing's going to happen if you clear out the equation. You just have to take the a dividing on the other side, and be careful with the signs, because both signs of x will be okay. So you're going to end up having that it converges if x is between minus 1 over a and 1 over a. And in these cases, these series converge. Now we say, and this is important terminology here, we will say that the series converge for the interval x belong to minus 1 over a to 1 over a. Okay, actually this is not correct, I think, because this should be an open interval. And the radius of convergence will be 1 over a. Okay. The important thing here is to understand the definition of the interval where it converges. Excuse me for the small mistake here. You should have brackets, and the radius of convergence to be 1 over a. That's the whole idea. So these are important things. This is the kind of stuff that they ask you to do in the exam. Find the radius of convergence, find the interval of convergence. That's the sort of thing you need to know. Let's go through a bit more of a complicated example. Okay, so look at this wonderful power series. Now, first of all, you might look at it and say, whoa, is this a power series at all? Yes, it is. Your a sub k, the thing that keeps changing for every term of the series, is going to be 1 over k to the power of 3. And your b, the thing you're subtracting from x, is going to be 2. And if you go back to the other formula, you realize that this is actually a power series. So when does it converge? Now, that's not going to be that easy. So what we're going to be using to determine the convergence of this thing is simply the ratio test. Why? You'll see in a minute. So let's take a look at the limits. Look, backtrack to the ratio test. You should remember if this thing here is smaller than 1, then it converges. If it's bigger, it diverges. And if it's equal to 1, we don't know. So, okay, there you go. We just plug in k plus 1 on the top and just leave the way it was on the bottom. And if we operate here, this is what we end up with, right? Because we're going to end up with x minus 2k to the power of k times x minus 2. The x minus 2 to the power of k cancels with the 1 on the bottom, right? You get this one's canceling. You get these ones, they don't cancel at all, and these ones don't cancel either. But this is essentially the expression you end up with. Now realize the following thing. K is always positive, right? Because it goes from 0 to infinity. So k is always positive. Hence, the only thing that can possibly be negative is going to be the x minus 2. So we can just say the following thing. We can just put the, okay, let's just leave the absolute value with the x minus 2. Take that thing out of the fraction. Let's leave this fraction here neatly outside. Because the only thing that really, this thing is multiplying anyway. We can move it outside. But the absolute value, it only really applies to this part. Because this one is always going to be positive. It doesn't really matter. Now here's the other realization. The limit is of k to infinity. Hence, this thing here has no k. I can take it out of the limit. Because it has no k, it's not going to matter. The result's going to be the same thing. Now, once you get to this point, you look at this limit here, and you should realize that this limit here is simply going to go to 1. And since this limit here is going to go to 1, this limit here is going to be equal to this, to x minus 2, because this is just 1. So this is equal to simply this times 1, and hence we end up with this wonderful expression. Now I need this thing to be smaller than 1. If it's smaller than 1, then I know it converges. And that happens if x is between 1 and 3. Great! It seems that we have our interval of convergence, but you're wrong. We don't have it completely because we still don't know exactly what happens when x equals 1 and x equals 3. So we need to find that out. Now, how do we find that out? Let's just substitute. We check for x equals 1. We substitute with an x, in the x we put a 1, and we end up with this thing. Now this, we know what it is, and you should recognize it. This is an alternating series. If we try to use a ratio test for this one, you're going to get 1, so that's not going to work. But it's an alternating series, so you need to have your two conditions. One, the limit goes to 0, check. And the other one, that uk plus 1 is smaller than uk. And that happens because the denominator keeps adding 1, so it's always going to be smaller. So check. Now we know the convergence when x equals 1. Let's check out for x equals 3. Now we substitute here, and we're going to end up with 3 minus 2, 1 over k, and now we're going to end up with this. This is going to just be a p-series. If you have to, you can prove that it converges using the integral test. But ultimately, we know the series converges when x equals 3. Hence, now I have my interval of convergence, including 1 and 3. I know that if it's smaller than something like 0.8, it's not going to converge, and I can prove that by the ratio test. But if x is between 1 and 3, including 1 and 3, it converges. So the interval of convergence is 1, 3, and the radius of convergence is 1. Think about if you're starting to understand why the radius is 1. Think about that between 1 and 3, I have 2. That would be, sort of to speak, my diameter of convergence. The radius would be half that. So it'd just be 1. Great, so that's how we determine the important things that you need to know about power series up to this point, which is interval of convergence and radius of convergence. When do these things converge? Because that's what's really going to matter. Now let me have a little corollary to this. Let me add a little something to this. When can I integrate and differentiate power series? This seems like you just mix two things together, but actually it's very important. Now, the most important thing to realize is that I will only be able to differentiate or integrate if they converge. If they converge, it's okay, you can go ahead and do it. If they don't converge, nope, you can't do it. And it should make sense because you keep getting bigger and bigger and bigger and bigger. How are you going to ever differentiate that thing? So all you have to do is do term by term, and that's going to be a very, very useful tool. Now, think about it. If we have this thing here, this is the same one that we had before, right? if we have this thing here, now we're integrating this crazy big thing here, this symmetry. Now the advantage of integrating series is that, you know, when you integrate something plus something, all you do is the integral of the first part and then the integral of the second part. So actually this thing is just going to be this. You see, I can take the symmetry and take it out, and now integrate this thing calmly and get the solution. But it's important to realize that I can only do it if it's in the interval of convergence, and this one happens to be in the interval of convergence, as we proved before. Be careful with this. This is an important, necessary condition. But I can just take the symmetry out, and if I take the symmetry out, I can just integrate this thing. Take the 1 over k over 3 here, do the integration. You can make the substitution with 2 and 1. This looks a bit messy, but if you're a bit patient, it actually will end up looking pretty neat. And that's the way you can integrate a series. So that's pretty much it. Thank you very much for watching. Goodbye.